Alright, continuing on in our conversation of the weld symbols and the information you're going to see on a weld symbol, let's talk about some of the stuff that you're not going to see that often. Once again, do note that even though this particular weld symbol shows everything on the other side of the arrowhead, or what we refer to as the top, above the reference line, doesn't mean that it's going to always be up there. It can be down below the reference line just as easily. The key thing is to understand that this information pretty much from here to here does not flip. The arrowhead, the all around, the field symbol, those flip. And I say flip, I mean they could be on this side or this side. The specifications and the tail could be on this side or this side. Just one little thing to keep in mind. Making sure that sinks in. So let's take a look at some of the other stuff. And by the other stuff, we're of course meaning the root opening, which we've learned what the root is. It's going to be located typically above the actual symbol for the probably the plug or slot welds. We'll see some examples of that. A contour symbol, a symbology that associates with, well actually we'll look at an example that makes more sense before I go into it. If the angle of the groove has a special angle, it can be located again above, and then a symbol of finish. Now, if we're dealing with a specific number of studs or projection welds, that number can be provided as well. And of course, you can see it down below here. So these kind of things, not going to see them as often in a set of plans, but if they do pop up, you'll just quickly hop to your reference guide that you've made for yourself, figure out what they are, and move on. Let's take a look at some actual examples of these. All right. Before we get in too far into those other features, I do want to hit this real quick. Again, when we talked about dimensions, we were talking about size, length, and pitch. And this is just a quick graphic to review that before we move on. Your basic weld here, when you don't see a length and pitch provided like you do in this situation, then you assume it's continuous. One thing that we should have provided is the actual size. And again, note that the arrow or the arrowhead is here, but the symbol is above the reference line, which means it's occurring on the other side, which is what we see here. All right, let's go down. Now, in the particular case of what we're seeing in this point is the root, the root weld, remember those things? Root added in, its overall size provided within the symbol itself. And that's interesting. Now, when we're dealing with the groove, a specific groove angle, you'll notice that again, like we saw on that previous image, the previous graphic, you see that the angle is included with the symbol. Again, noting that even though they showed it up here on your reference, doesn't mean it actually stays with the symbol down below. And when a person actually sees the degree symbol, they should know that we're dealing with something, especially if they see a groove weld with 30 degrees, that means it's going to go down. Notice that again, the arrow is pointing to this top surface, where the groove weld is occurring, the symbol's below, which means it's going to occur on the arrow side, so you can see the groove weld was done this way. Alright, so now we have a different symbol for a square groove weld, but you'll notice that its particular size or depth of penetration is in parentheses to the left. Remember we saw that? Notice the parentheses represents the actual penetration depth, not so much actually we should say the size. Alright? And length and pitch, like I drew out previously, this is just a graphic way of showing that type of intermittent weld. You'll notice that they actually measure from center to center, but again, mind you, a pitch can also be from starting edge to starting edge, or it can be from trailing edge to trailing edge. It doesn't matter, it's going to be the same value in each case. Alright, so let's talk now about the tail. Now we've mentioned in terms of the tail, it's either going to be shown or not shown. If there's no information to be provided, you won't see a tail. But if there is some information to be provided, you're going to see it in this way. So for example, you've got your tail occurring here, and you've got the det.b. Now this particular case just means that a person's going to need to reference detail B, which will be somewhere on the drawing. You're not supposed to know exactly what detail B means. It's just going to be saying to you, hey, there's some more information about this particular weld located on this drawing under detail B. And designers will use this tail for extra information all the time to throw in odd little things like that. So keep that in mind. Let's see, specific information. You know, you're basically going to use this to specify a particular process. So you've got your weld symbol, your location of it, and then what type of process you're going to use. When they put in MA, means manual application. Now this one's good. This one is specific to a manufacturer, and this is a situation where a manufacturer has a particular way they like to do things, specifically in the welding process. So they would have standards and things that they would teach their employees, and then this is essentially a call out. So instead of just putting a generic detail or generic note in there about some kind of welding process, they're calling out their process, that you would go and look at their process or provide their specific way of doing it based on their number system. So this is not a number that you would know. This is something they would say, hey, our SW-017 is a such and such process that you do such and such a way. So when you see it on the plans, you go do what they want to do in that particular case. And again, note that when there's no information, there's going to be no tail on the plans. Now, another quick little note about the tail. There's other information that you put in there. I put, obviously typical, but they may put in something like this, which, hopefully from the blueprint experience that you have or other information, you know that this means a occurrence of 4 places. Or they could say something like this, where they actually write TYP, by 6, which means this is going to be a typical weld process that's going to occur 6 times. If they don't put a number in there, then you just assume it occurs every time that you have a similar joint situation or wherever the arrow touches. But by adding the value, typically in the form of a by number, or sometimes it can be by this number, but most of the time though it's going to be in front of in this particular scenario, it does imply that there's going to be a case number of it. Now also keep in mind on some prints though, they can actually provide this in a 4 by, a diameter, 0.25. This is referencing other blueprint stuff. You can see the number before the multiplication sign. Obviously it doesn't mean multiply, it just means there are 4 cases of a 0.25 diameter. This means there are 6 cases of this type of weld. So don't get locked in on where the number is versus the multiplication sign or the by sign, or X if you will. It can be either side and still mean essentially the same thing. So now let's take a look at all these supplementary symbols, the extra little things that we see or we don't see. Now we've already talked about one of them, or actually 2 or 3 of them by this point. And of course we have things like the field weld symbol, which we saw was a flag. And depending on where it is doesn't really matter, it just means that this type of weld process is going to occur in the field, which is pretty easy to understand. Also, we've got the all-around symbol, which means essentially that it's going to be welding all the way around. So this keeps them from having to actually put a bunch of arrowheads down. When you see this symbol, it means all the way around. And in this particular case, for example, here we have an angle, an L bracket, which is going to be welded to something below, or I guess on this plate. And you can see the description of welded all the way around. So it's not this side or that side, it is all around. Now let's take a look while we're at the field weld symbol. Nothing special about it, just means that you're not going to do it in-house, you're going to do it on the site. Nothing really big deal there. However, there are some other symbols. Let's actually take a look at them up here first. So we've got the melt through symbol, the consumable insert, the backing, the flush or flat, and of course these are under the contour symbols, that little symbol above. You'll notice they can be a straight line, a curve, or inverted, or convex or concave. And notice that your backing or spacer rectangle can be in the reference line or kind of above or below, depending on the application. Let's take a look at some examples. Alright, melt through symbol provided. Not too big of a deal, except that they do provide the actual size of the melt through point. And of course you see it's provided on the other side of the weld. So your main weld's occurring on this side, your main groove weld's over here, your melt through point referenced on the other side because it's on top of the arrow. Little glob shape will be on the detail. If you're going to use some consumable inserts, you have a nice little graphic here that kind of shows the overall process. Notice that you're going to have a box above or below, depending on where the weld's going to occur, and a class number. Now, of course, the class is established by the AWS and their publications, but essentially you're going to have an insert that is going to become part of the weld and melted into the process. So, you have some classes right here, class 1 through 5, class 4, nice little feature there. Class 1 kind of shapes like a mushroom or rivet. And again, this does get consumed in the process and binds to the overall weld. Take a look. Spacer, this is going to use something, again, a spacer is the same concept, except it's used to hold apart, pieces apart. It does get consumed in the process. So whereas the previous one is actually a material as a filler, the spacer is actually used for a holding position almost, and you can see it consumed in. Its specification is a little bit different. You can notice that the dimension of the spacer is located in the tail, and the spacer shape or symbol is provided there. Backing again is a little bit different. It's not actually consumed in the process. It is more of a component for a stopping feature, but you can see it there. Flush contour, this is that symbol above or below, and you can see the difference between a line, convex or concave. You notice that it shows that the finish of the weld needs to be flat on the top surface. It needs to be convex over, or in this case concave on the weld side or the arrow side to slope in. So each of these are just a finish that you'll see, not as common as just the main symbols, the other things that we've looked at, but extra information here. Now these are all standard AWS type of symbology. So again, you can do an internet search, find this information, and add it to your particular records without a bit of problem. And it's important that you do that, maybe even take pictures of text or that kind of thing with your smart device to keep that for quick and easy access when the time comes. All right, that's a good stopping point. So we'll pick up with the rest of the material here in a little bit. We'll see you.